Hi everyone, in this video I'm going to discuss the concept of skewness and kurtosis. First, I'm going to talk about the concept of skewness. Okay, so the concept of skewness is whether what is the distribution, how your data distributed, so it's how symmetric is your data distribution, whether symmetric or asymmetric. So skewness looks at how symmetric. So I'm going to just say it looks at how symmetric is your data distribution. Okay. So how symmetric is your data distribution? That's what skewness looks at. There are two ways to discuss skewness. One way is to look at the graphs, and another way is by doing calculation using the Skewness formula. The first thing I want to do in this video is to show you how you can see it from the graphs, from the distribution plot here. Okay. So first one, right? First one, as you can see, is not very symmetric because the tail is long in the left side, but not too long to the right, So as you can see, it's not symmetric. All these are kind of comparing to normal distribution. Okay, cool. So this one is not too symmetric and it's to the left. So if you are presented this type of distribution, there are three ways to describe it. And then the first way says negative direction, so it's negative direction. First way to say this, and then this is negatively skewed, okay, and also it's called left skew, okay, left skews, perfect. So in the middle, the way I drew this plot is to assume that this is a perfect symmetric normal distribution where the two tails are symmetric, so in this case we assume that it's symmetric. So if you're presenting a symmetric normal distribution like this is just normal, right? We call it normal or no skew. No skewed. Okay. Now this one is the opposite of the one on the top, right? As you can see, the tail is to the right hand side, whereas long tail here, but not too long tail here, right? So it's again not symmetric. In this case, it's a positive direction. Positively skewed, and or right skewed. Okay, right? So this is simple, right? You look at the graph and then you look at the tails and then you can decide which type it is. Cool. So this is how you're going to do it by looking at the graphs. Next, we're going to do it from calculation. Okay, so we're going to use the Skewness formula. So we're going to use the Skewness formula here. Okay, so the formula skewed equals to M3. The 3 subscript here over sigma cube, right? So M3 is our third central moment. Okay, and then sigma cube, it's just the standard deviation, and then you cube the value, right? So that's just standard deviation, and you cube the value. Okay, perfect. And based on the value you get, you can decide whether it's no skew, left skew, or right skew. So if this skew value equals 0, you have no skew. Okay. If the skew is less than 0, then you have a left skew, right? Okay, so the top, left skew. Good. Okay. And if the skew value is greater than 0, you have a right skew. Okay, very good. Okay, 3 cases, right? So you can either look at the graphs, or if you only have a set of numbers, data, then you're gonna use this calculation formula here. Perfect. Now I want to do an example to show you how you would use this formula here. Okay, so in this example, I'll be using the exactly same set of numbers in my moments video, right? So would be the example presented in the moment video. So I'm using example from the previous moments video. Okay, so from that video we got the third central moment, or M3 equals to 5.4, right? So we got that. We got this value from the previous video. And then we need the second central moment to get the standard deviation and then get the standard deviation cube. So our second central moment, which is our variance, in our previous video equals to 4.2. Okay, so if we have the variance to be 4.2, then our standard deviation is the square root of this number. 4.2, that's equals to 2.05. Okay, so we have this number here, and we have this standard deviation here. So we are ready to calculate the skewness. Okay, so let me get the skew number equals to M3 and then say my cube. So that's equals to 5.4, right? 5.4 here divided by 2.05 to the cube. And that's equals to 0.6268. Okay, so this is our skewness index, or the number we get from the formula. Now we're going to compare to this one. Right? 0.6268 is greater than 0. So the conclusion is we're going to have a right skewed or positively skewed. So we have a right skewed or positively skewed. Okay? Right. So this is how you would use the formula to check the distribution of that, whether it's right skewed or left skewed. Okay. Next. So the next concept I want to talk about in this video is kurtosis. So kurtosis looks at the peakness of your distribution. You know how peak it is, and it's kind of one step above. There's skewness, right? So skewness looks at symmetric, and kurtosis looks at the peak. Okay. Next topic. Kurtosis, right? Kurtosis looks at the peakness of a distribution. Okay, peakness of distribution. Okay, so when we talk about the peakness of distribution, we are comparing it to the normal distribution, right? So we're always comparing the distribution we have on hand to the normal distribution. So we're going to compare with normal distribution. Okay, we're always comparing to the normal distribution. Okay, so now let me quickly do a normal distribution first. So the one in the middle, let's say this is normal distribution. Okay. So imagine this is the normal distribution. This one is the normal, right? Imagine this is the perfect normal distribution. If the distribution from our data set, or the distribution we have on hand, it's steeper, or the peak is higher than the normal distribution, if we have a distribution like this, right? That's really feel like the peak is above the normal, right? This type we call leptokurtic. Okay, right? So the peak is higher than normal distribution, right? This leptokurtic. Okay, cool. And then if the distribution you have on hand is like flatter, right? Flatter than normal distribution, if it's more flat, right? So say it's more flat, right? Imagine this, yeah. So if it's more flat, then this is what we call platykurtic. Okay. Okay, right? So if the peakness is flat than normal, then this is like a higher or steeper than the normal distribution of this type. Okay, perfect. So what if it's exactly normal? If exactly the same as normal, so exactly same as a normal distribution, then we have mesokurtic. Okay. So this is how you would get the result, get the type from looking at the graph, from a plot. Okay. Just the same as our skewness, we are also able to get it from a formula. So if you have a set of data, and you want to get it from the data itself without plotting it, then you can get it from this formula here. Okay, the formula kurtosis formula. Okay, let me just denote it with K. Kurtosis equals to M4 subscript 4 and then sigma 4 power. And then M4 is our fourth central moment. And then sigma 4 power, just standard deviation to the fourth power. Okay? And the way you decide is looking at the value of K. So if K exactly equals to 3, that's our normal distribution. So that's our mesokurtic. If K is less than 3, there's a platykurtic, which is the flat case, and then K is more greater than 3. Okay. So you're going to use this formula, compare 3 to decide which type you have. Okay, cool. Now I want to again do an example to demonstrate to you how you will calculate these values and how you will make a decision. We'll again be using the example we used in the moment video. Okay, so example, right? So it's the one from the moment video. Example, right? K goes to M4, and then sigma 4. Do we have this one? Yes, but we need this one. So we'll have to calculate for the fourth central moment. So fourth central moment. This one we did not calculate in the previous video, so we have to calculate it now. It's 1 minus 4. Remember the 4 was the mean. So this was for the 4th to the 4th power, plus 2 to 4 power, plus 3 minus 4. I'll just continue to write them out. Plus 3 plus 4. Plus 4 from plus minus 4. Okay, plus 5 minus 4. 4 plus 7 to plus 8 to 4. 4. Okay, right? And then everything you're going to divide by n, which is 10 again. So this, after some calculation, you will get 43.8. And that's our fourth central moment here. And then we're going to continue with this formula. Okay, our K equals to the fourth central moment, which is 43.8 divided by the standard deviation to the fourth power, which is 2.05 to the fourth. We got it from the previous example, and that's approximately equals to 2.48, right? Now you're going to compare this number with 3. So since 2.48 is less than 3, the P-next type we have, the kurtosis we have is platypertic. Okay, very good, perfect. So this concludes our topic of skewness and kurtosis, and I'll see you in the next video. Thank you for watching.